Dear students, in this lecture on convergence of series of real numbers, we will study comparison test in limit form for series of real numbers. Let us see comparison test in limit form for convergence. So, what is the hypothesis here? The series Bn converges absolutely. And second hypothesis, limit of mod an upon mod bn as n tends to infinity exists finitely. The conclusion is that mod an converges absolutely. So let us see proof of this comparison test in limit form. We begin with the hypothesis that limit of mod an upon bn exists. Hence, the sequence mod an upon mod bn is bounded. So it is bounded sequence. As it is bounded, there is m greater than 0 such that mod an upon mod bn is less equal to m. That is, mod an is less equal to mod m times mod bn for all n belongs to I. So in other words, we can say that series an is dominated by series mbn, but it is given that the series bn converges absolutely, that is mod bn is convergent. Hence the series mod m into mod bn is also convergent. Okay, thus if this series is convergent, then its sequence of partial sums is also convergent. Now we are in a position to apply comparison test in absolute form. Basically, what comparison test in absolute form says? If bigger series is convergent, so in this case this is the bigger series. If bigger series is convergent, then smaller series is also convergent. So by using comparison test, we can conclude that this series mod an is convergent. So basically, comparison test in limit form for convergence says that if limit exists finitely and if series mod bn converges absolutely, then series in numerator, that is series an, also converges absolutely. Let us see comparison test in limit form for divergence. So we will see a comparison test in limit form for divergence. The statement is that, or hypothesis is that, series mod an is divergent. This is first hypothesis. The second hypothesis is that limit of the sequence mod an upon mod bn exists finitely. The conclusion is that series Bn is divergent. This is our conclusion, that series Bn, mod Bn, is divergent. So with these two hypotheses, we are now in a position to prove comparison test in limit form for divergence. We begin with the given hypothesis that limit of mod an upon mod bn exists. As the limit exists, the sequence mod an upon mod bn is bounded. Mod an upon mod bn, this sequence is bounded. It is bounded. So there is m greater than 0 such that mod an upon mod bn is less equal to m, that is mod an is less equal to m times mod bn for all n belongs to I. By the definition of dominance of series, we can now say that series an is dominated by series mbn. In other words, the series 1 upon m an is dominated by series bn. We can now apply comparison test in absolute form. So the bigger series is convergent, hence the smaller series, here the smaller series is divergent, hence the bigger series is divergent. So if the smaller series is divergent, then bigger series is also divergent. So Bn is going to diverge. Before that, let me ask a question or clear the doubt that why does the series 1 upon m an diverges? I mean, why the series 1 upon m mod an diverges? Because it is given that the series mod an itself diverges. It is given that this series is divergent. So that's why this series is also divergent. Okay. Now smaller series is divergent, hence bigger series is divergent, that is series mod bn is divergent. So this is the comparison test in limit form for divergence. We have also seen comparison test in limit form for convergence. Basically, we can say that if limit mod an upon mod bn exists finitely, and if one of the series is convergent or divergent, then other series is also convergent or divergent. We often say or describe this as by saying the fact that series mod an and series mod bn converge or diverge together. Thank you.